So in the given LR circuit, what is the variation of the current I as a function of time? அப்போ இங்க இந்த I variation as a function of time கேக்குறாங்க. So they are asking I is going to vary with respect to time. So what is that equation? That is what they are asking. So this switch is also closed at t is equal to 0, it is closed. So actually they are asking a function, don't substitute t is equal to 0. Okay, they are asking a function of current. About here if you see this circuit, here I have I, here I have 3 volt. If some current is coming here, that current will split into 2. So here for simplicity we can give some names. If this is I1, this is I2. So here if you apply junction rule, your I1 should be equal to I plus I2. So basically they are asking I is what? It's a function of time. I is nothing but I1 plus I2. Sorry, I1 minus I2. Let me find I1, I2 separately and then we can substitute in this equation, we will get the answer. So first let me find what is I2. So I want to find what is I2. So I2 means I can use this loop. Only we have 2 loops here, one loop and then loop. Third loop also we can take if needed, this loop. First we can take this loop. So apply Kirchhoff's voltage loop rule. So current is flowing in this direction. So here minus 2 volt and the loop comes here and plus V, that is 1V, and here current is coming in the opposite direction. So plus I2R will be equal to 0. So here minus V plus I2R will be equal to 0. So I2 directly we are getting, it is simply V by R. So very simple. So V by R. Now let me find what is I1. Okay, so let me go through this loop. Let me apply Kirchhoff's voltage loop rule to this loop. If I apply, let me start from here. Okay, if I start from here, what I'll get? So here I'll get 3 volt, and then again the current flowing here is I1. So in the same direction, so minus I1 into R, and then here the current is going to grow. Correct? If the current is going to grow, it will try to opposite. Okay, then it will be like this. Correct, the EMF produced by the inductor. So let me put minus L into di, current flowing here is what, I1. So di1 by dt, it's a variable. And then what I can do when it comes here, that is minus I2 into R and then minus V here and then closes is equal to 0. So this is what the equation we are getting. From this we have to extract what is I1. Okay, so let me extract that also. Here 3V minus V, I'll get 2V. Okay, minus I1 into R. Okay, this I can't do anything. Let me put it as I1 into R itself. Okay, and minus L into di by dt, which is equal to 0. Here I missed I2R also, na. Here minus I2R. So here we know I2 is what, V by R. If I substitute this V by R here, R will get cancelled. I will get directly minus V. Correct, is equal to 0. If I substitute that minus V, 2V minus V is what? Again I will get V. So directly I will write V is equal to 0. So V minus I1 R minus L into di by dt is equal to 0. So here our idea is to find what is I1. Correct. So let me stick to that. So I1 R, which is equal to V minus L into di by dt. This is what the equation we are getting. So once again let me erase everything. Okay, so I1 into R, which is equal to V minus L into di by dt. So di by dt, we know I, growth of a current in a conductor, is what? It is simply I naught into 1 minus e to the power minus t by tau. So I naught is nothing but V by R. Okay, so total voltage given V by R, 1 minus e to the power minus t by tau. So now this is what the current we have, but here I have di by dt. So if you apply that and find what is di by dt, what we will get? v by r is a constant, 1 is a constant, differentiated you will get 0. So minus of, if you differentiate this, e to the power minus t by tau, again if you differentiate this, you will get what? You will get minus 1 by tau. So you will get the answer as v by r. Okay, so e to the power minus t by tau divided by tau. This is what we are getting. If I substitute that here, instead of L into di by dt, I'll get v by r e to the power minus t by tau by tau. Okay, this is what I am getting. So take v in common. Okay, so if you take v in common, what I'll get? 1 minus L by r tau into e to the power minus t by tau. So here v, okay, I1 only we need, we can bring this r down. So v by r. Here if you see this tau, what is this tau? Tau is nothing but L by r, or L by r is nothing but tau. So both of them will cancel each other. So e to the power minus t by tau. So this is what we are getting. Directly we can substitute this in this equation. I, which is equal to I minus I2 na. I1 is what? I1 just now we got it. What is that? V by r. It is simply v by r 1 minus e to the power minus t by tau. Okay, 1 minus e to the power minus tau by tau, t by tau. So this is what your I1 minus I2 is what? We already found v by r. So this is v by r. So again in this v by r is common, we can take v by r common. So what we will get? So plus 1, if I take this v by r out, again I'll get minus 1. So plus 1 minus 1 will get cancelled. So I'll get minus e to the power minus t by tau. This is what I will get. Any options are like that? So minus also we are having, minus only we have here. So minus v by r into e to the power, that is tau, if you expand it is L by r. Okay, so we will get this as the answer. Okay, so I hope you understood how to find the answer.